It's podcast 31.
31. Well, I'm excited. What have we got coming up?
We're going to have a little chat, as promised, about Orion.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
The glorious Orion. This is good, actually, isn't it? Because I don't think many people will know all of the facts about the glory that is Orion.
I know, it's amazing, actually. Do you know what? One of the best things about the last couple of episodes with Marcus was that he actually has forced me to look into a few things, which have been really interesting. Particularly the heat shield on Orion is actually genuinely really interesting. There's some good stuff in there. So yeah, we could talk about it. But Jamie, it's the Interplanetary Podcast,
putting the
A's back into space. you didn't do that
it's
with
seamless.
much enthusiasm.
I was. I don't know.
You just weren't pumped up.
I was worried about timing, and ironically, mucked the timing up.
But by the way, James, this Orion that we're going to talk about is not the Orion that we've talked about before, which was the nuclear propulsion Orion that's for interstellar travel. Yes. It's really quite exciting because this is going to be the first vehicle really that's really gone much further than the moon, so it should be eventually capable of getting to Mars.
So what does MPCV stand for, Matthew?
It stands for the Multi-Purpose Crew Vehicle. And see, Orion didn't start off as part of this. Orion's had a bit of a long and kind of checkered history because it wasn't. It almost got scrapped because it was part of the Constellation program, right? That I believe George Bush started. And the Constellation program was a big sort of push to the moon and to Mars with the Ares vehicle and Orion. But they scrapped it because it was miles behind schedule, etc., etc. And so the only thing that survived is the Orion Crew vehicle. Okay. And the only way they made it survive was to make it slightly more adaptable. So instead of having lots of versions, it's just one multi-purpose crew vehicle.
I like it. Okay.
So it can go up to low Earth orbit and deliver people up to the space station, or it can go to the moon, or it can go to Mars. So it's got a sort of 2 to 6 people capacity. Obviously, you wouldn't send 6 people to Mars in it because it would be pretty cramped and horrible. But you could just about send 6 people up to the space station in it. Yeah. So that's, So,
that's awesome. Well, what a versatile craft. It's got my endorsement.
No, it's pretty expensive, though. So, go on. So the Orion project has been costing the US taxpayer $3 each every single year.
$3 each every year.
So we're talking billions of dollars each year being spent on the Orion program.
See, it doesn't sound like much, but then there are 300 million Americans.
Not all taxpayers, but I mean, it's obviously hugely expensive, and of people that work on the project, obviously for them, they sort of their biggest challenge is really keeping the funding going because there's all these schedules that they have to meet and all the sort of technical stuff that has to be done. And this is the brilliant thing about looking into this is the fact that you realise just how complicated these projects are. And that's what winds me up so much about the conspiracists out there is because they just don't understand how hard these things are, and then they just learn a small fact and go, oh well, it can't be true then.
That's pretty accurate.
So it's really so let's just have a look at some of these facts. So
you're going to pull some stats out if I know you.
I might pull some stats out here. So
here we go.
So the space station is only 205 miles away on average.
Right.
The moon is 239,000 miles away. So it's
just about to say
1,000 times
that.
further. So it's like 3 orders of magnitude further away. So it's like, it's a different thing, different ball game.
Now, Matt, I know that a lot of people have seen the graphic, but it is mad that you can actually fit all of the planets in the solar system between the Earth and the moon.
I know.
I mean, that's
it is
unbelievable,
a crazy one,
isn't it?
No, that is absolutely bonkers.
Especially when you think about the size of Jupiter.
Here's
for
one.
example.
I wonder if you can fit every single exoplanet discovered so far between Earth and Mars. Because that's 39 million miles away. So that's when it's closest. So
okay.
39 million miles away. And obviously sometimes it's more like 150 million miles away.
Yes.
So these are the kind of crazy things that this Orion spacecraft is built for. So obviously one of the striking things, and I think this is probably why most people don't sort of look at Orion and go, "Oh, I must learn more about that," is because it's got that familiar capsule design. So
Absolutely.
it's not like, "Oh my God, look at this spaceship that they're building."
Yeah, it's not wacky looking, yeah.
No, it's not wacky looking. So it is pretty much based on the Apollo capsules. So nothing big there, but it's 60% bigger than Apollo. So so it's got a 5-meter diameter rather than a 3.9-meter diameter, and as I pointed out to Marcus, that's a massive difference in surface area. So for the heat shield,
Absolutely.
so it can fit up to 6 crew, and Apollo was only built for 3. And it can go obviously much longer into deep space, but to do that, obviously you need kind of a few things. Although I believe just the Orion MPCV with the European service module should last for 21 days. So you should be able to sort of stay in it for 21 days, which if you think of a vehicle that small, is pretty amazing, isn't it? It's like
it is pretty amazing.
Imagine being stuck in a splitter bus for 21 days.
Well, I've done it. Yeah. It's not pretty. I mean, at least I got to get out occasionally.
Yeah, I mean, yeah. Hopefully, you went into a venue every now and then.
Yeah, occasionally touring life.
Just went on tour, but didn't actually play any shows.
This is it.
So the Orion module itself is a partnership mainly between NASA and Lockheed Martin. Although actually, loads of the parts are built by lots and lots of American businesses all across America.
Right.
But I believe the kind of main people that work on Orion all have to be American citizens because of the national interest in there. But
well, you don't want to
Orion's...
upset people paying $3 a day.
No, you don't.
Where was he born? Ridiculous.
But NASA, to save money, went to the European Space Agency and said, "Oh, you remember your ATV, the automated transfer vehicle? Do you fancy basically making a successor to that, and it can become the Orion service module?" So I don't know if you remember the ATV, Jamie. You might be too young. Well, big time.
Yeah.
Can you remember some of the names of some of the ATVs that flew up to the International Space Station?
Well, I know Jules Verne was one.
Whoa!
And so was Mr. Kepler.
Johann.
And we couldn't not mention the big dog himself, Albert Einstein.
The Albert Einstein ATV.
Yeah.
Are you going to go for another one?
No, I think that's it.
I'm going to go with Georges Lemaitre. But anyway, the ATV used to carry stuff up to the International Space Station. Not only did it do that, it used to dock and boost the ISS into better orbits.
Yeah.
But it's never been used for transporting passengers.
Aha. Okay.
Yeah. So in 2012, ESA announced that they were going to terminate the ATV program. So we haven't had one since 2014. But now it's going to go on, and they're going to sort of develop it into the service module for the Orion.
When you say terminated, did it lower into molten metal with its thumb up, like in Terminator 2?
You're terminated.
I'll be back into orbit.
I'll be back as the Orion. service module.
We apologise to any Austrians listening.
Well, of course, Albert Einstein. Was Albert Einstein Austrian? No, he wasn't. He was Swiss.
No, that was Hitler.
I don't know. I can never remember. Von Braun's mate. Anyway,
Oh, God, yeah.
so let's have a look at some comparisons between Apollo service module and the Orion service module.
Let's do it.
So the Orion service module is pretty much twice as powerful in terms of its electricity. It's a whopping 11.2 kilowatts.
Woo.
But it weighs nearly 40% less when fueled.
Okay.
12% smaller. But
Right.
it has a third less delta V. And if you're wondering what delta V is, it's a kind of measurement of how much fuel you need to actually push it around the solar system.
Right, okay.
Yeah, it's got something to do with specific impulse, and it's just a measure of it's a thing that you can stick into the rocket equation to work out how far and how many manoeuvres you can make as you go around.
Got it. Okay.
So those people playing Kerbal know all about it, but us mere mortals have got no idea what the hell they're talking about.
We don't know.
Yes, and the Orion service module should be able to support a crew of 4 for 21 days, but the Apollo could only do 14. There we go.
Got it.
So obviously on the way to Mars, that's nowhere near enough. That's nowhere near enough to get to Mars. So there's another part to this whole program, and that's the deep space habitat.
Oh, yes.
And some of the drawings of the deep space habitat look really, really cool. So
I'm
I'll stick
looking at them
up on
right
the
now.
blog.
They're awesome.
Yeah, little men jumping around inside a tube, essentially.
Yes.
But yeah, so Orion obviously would dock with the deep space habitat and go off to Mars. Well, that's the plan, anyway. And I'll actually get on to the really exciting bit of some of the recent news that we didn't talk about when it was announced, but we should do on this one because there's some pretty cool things in the pipeline. Mm-hmm. So the crew module, it has improved waste management facilities with a miniature camping-style toilet and a unisex relief tube like the one on the space shuttle.
Relief tube?
We did talk about this when we had a small
but did we ever say relief tube? I don't think that's ever come up, has it?
No, I don't think I've said unisex.
I think I'd remember
tube.
those two words if they were put together.
But I tell you what, if you really want to listen to a really great episode about poop and pee in space, Are We There Yet podcast has just done a really, really good one. So
we love
check that out.
For sure, check it out.
Yeah, it's really, really good. But someone's just won a NASA prize by coming up with a novel solution.
I'm glad we're not the only ones who, get down to basics.
I did. There's always a lot of moaning about when people talk about poop and pee in space, but I'm digging it.
It's just natural.
Yep, natural.
You're digging it.
Dear. So it's designed for deep space re-entry at 20,000 miles an hour, and it's got a stable shape. And I'm going to talk about this stable shape a little bit later on.
Yeah.
But one of the really cool things about Orion, it's also built with an open architecture. So as it gets older, you can take out these generic parts, so the parts inside, like the computers and things like that, as generic as possible, so that as improvements come along, you can make them better. So you can slot in the new improved versions.
It's like a human body getting a new liver or a new lung.
Yeah. So the really cool thing, just like Apollo, the actual capsule is actually slightly crooked.
Right.
And the crookedness means that as it goes into the atmosphere, it kind of has it sort of tilts over into an angle of attack.
Right.
Which gives it a kind of aerodynamic stability once it's going faster than Mach 5 and reaches the hypersonic flight regime.
Nice.
It stabilizes, and the angle of attack causes Orion to have a tiny bit of lift, and then with that lift, they can steer the vehicle and control the entry trajectory by banking, like a glider. How cool is that? So it's just the fact that its mass is slightly off balance that gives it that ability to actually steer in the atmosphere despite being a massive fireball at the time.
I wonder if there's a video online that shows that we can see kind of like a recreation. That'd be cool.
There's lots of simulations of it, but it's almost impossible to film that. Although there's some brilliant Orion footage, because one of there has been an Orion capsule that has gone into space. So the Exploration and Flight Test 1 did go up on December the 5th in 2014 and did an orbit of the Earth, and then went miles out and then came back and went through the atmosphere. In fact, it went through the Van Allen belts, and it's actually this is one of this Kelly Smith's video about the Orion capsule going through the Van Allen belts and saying, we've got to sort this radiation problem out. We've got to sort it out for Orion. It's been done for Apollo.
Okay.
And I'll get on to one of the reasons why it's different for Orion, because a lot of it's to do with the electronics. The electronics have to be super, super stable. And I saw a really cool thing earlier on in the week, which I wrote a little kind of blog about, the little chips in spacecraft, which is really exciting. So the Orion itself is really came out of the need to retire the space shuttle, because everyone realised that the goddamn thing was too unsafe, really.
Right.
Because and so it's designed to be 10 times safer than the space shuttle.
10 times.
It's a very, very severe problem, and the cosmonauts are right to say, radiation in space is a bad problem. Of course it is.
Yeah.
But it's not an insurmountable one; it's a solvable one, and that's what they do.
It's bad if you were to stick your head out along the way, like on a dog on a car journey,
or just hang out.
Yeah,
just hang out in the radiation.
Maybe just don't do that, and then you'll be all right.
Yeah. So there's 5 Orions. I think I've worked out roughly 5 Orions. I think have been built so far. So there's an Orion capsule that the astronauts train in.
Yeah.
There's the Exploration Flight Test 1, which we just talked about. Mm-hmm. There's a boilerplate test article version, which is a boilerplate, again, is that pretty much everything except all the things like life support in there. There's the ground test article, and there's the drop test article. So they do lots of drop tests into water and things like that, and see how it hits the ocean and things like that.
Right.
So I think there's kind of 5 of them. But here's an interesting thing: is that someone said, are the computers on Orion going to be really, really fast? But because every 10 to 15 years we should have like ludicrously fast
modern technology.
Modern technology. However, the computer chips in spacecraft really, really lag behind the the ones in your smartphone or the ones in your computer.
Right.
So. And the reason for that is because actually you don't need like stupidly fast processing speeds, because you're only getting your chip to do one thing. It's not designed to have Facebook up and to have Pro Tools running and doing a bit of video editing.
Yeah,
it's not that it's not designed to do that. So it's just making sure your engines work. Now the thing that it's got to be is totally resistant to radiation. So. Boeing make the RAD 750, for example, which is a chip that gets used a lot in lots and lots and lots of spacecraft, including Curiosity rover and things like this. And really, that's based on the chip that used to go in Power Macs and Nintendo Wii's.
No way.
Yeah, so it's kind of really a late 90s chip.
Right.
But it's fast enough. But the point is that the difference between the one that went in the Nintendo Wii is the fact that it can only withstand a small amount of rads of radiation, whereas this thing can stand up to a million rads of radiation. That like massively.
So if you're on the Orion blasting through space, you can play Wii bowling and you'll be fine.
Yeah, exactly. and it takes half the power as well. So these chips are, but the hilarious thing. So say if you bought a Nintendo Wii chip, it would probably cost you about a tenner these days. Whereas these chips are more like £250,000. And so each chip, like motherboard with these chips on, £250,000, and you think you've got to have one of those for lots of different parts of the spacecraft. So you can see how they get really expensive just from the chips alone.
Yeah,
but like a 1,000 rads of radiation would completely destroy your mobile phone. But not only that, when radiation hits your phone, it could actually change the calculation that it's doing. So it might knock one of the chip a naught into a 1, for example, and then suddenly the calculation it's doing is wrong. Well, it would be death if you're travelling into the Earth's atmosphere as a fireball, and everything needs to be worked perfectly. So that's why they're very, very expensive, and that's why you have to make sure that the radiation element is right, because the chips that we use in modern spaceships are much more susceptible than the old stuff.
That's amazing. That kind of God, that really is expensive. So the phrase "cheap as chips" definitely gets debunked now.
Yeah, it's like the opposite. As expensive as space chips.
Yeah, it's our new phrase. I like it.
Absolutely. So that's quite cool. And now I'll tell you what's an amazing video if you see it is the pad abort test that they've done with the Orion system, which I believe is actually very, very similar to the SpaceX Dragon launch abort system.
Yeah,
and it propels the crew from 0 to 490 miles an hour in 3 seconds.
That's ridiculous.
So if anything goes wrong with the rocket, this thing just goes bang and off it goes. And the video of the pad abort is amazing. You think, oh my God, that is just
that makes
incredible.
The fastest car on Earth seem like an absolute joke, doesn't it?
It really does, particularly so you're going up, you're not even going across. So no, absolutely, it's insane. You've got to watch that video. It's so amazing. But most of that acceleration is in the first fraction of a second, and so they feel these huge G-forces, but it's for very short time, and then it's sort of, I think it's like 11G or something like that they feel for a fraction of a second, then it drops down to about 7.5, so still absolutely horrendous. But that's why the seats are angled exactly how they are, so in the event of a launch abort that you don't pass out.
Okay. Nice.
It's cool, huh?
Very cool.
And then there's the heat shield, and this is what started my interest in the Orion thing with the heat shield thing, because I wanted to look all about it. Now, I've got a really... I was reading my SpaceX Dragon book.
You geek.
And there's a really good description of a heat shield and how it works.
Yeah.
So there's actually two different ways of heat shielding. Now, the space shuttle did it in a different way by having those tiles.
Yeah.
But the thing about the way that the shuttle worked was when those tiles failed, unfortunately, that did result in the death of the astronauts. Right. So even though it was a brand new system, it kind of, people are moving away from the tile system, because it only takes one of those tiles to fall off or to fail, and you're in big trouble.
Yeah.
When they were testing it for Orion, they tested 8 different materials.
Yeah.
They kind of abandoned the space shuttle tile system and went for this ablative thing. So they tested 8 materials. One was Avcoat, and one was Pica. And they eventually went with Avcoat, which is the opposite of what SpaceX have done. And SpaceX have gone for Pica. But because Pica was so expensive, they decided to make their own with the help of NASA, and they call it Pica X. So they are slightly different. But an ablative heat shield works by the decay of the spacecraft's outer layer of skin, because by the tremendous heating during re-entry speeds. This decay occurs due to convection, which in turn is caused by the pyrolyzing layer that diffuses in the direction of the heated area of the shield. Here, a boundary layer is created by the pressure of re-entry, and it's this layer that ensures the heat is redirected away from the shield.
See, that's amazing, and actually that proves that this is not by any means just a simple cover that they've plonked on, made of a specific substance. It's like, come on.
Yeah, I know. Well, listen to this. I mean, so the heat shield was composed of a titanium skeleton carbon fibre skin that gave the crew module its circular shape on the bottom and provides structural support, on top of which fiberglass phenolinic honeycomb structure was placed. The honeycomb structure had 320,000 tiny cells that were individually filled by hand with an ablative material called Avcoat, designed to wear away as the Orion returned to Earth. During the labour-intensive process, each individual cell was filled by hand as part of the serial process, cured in a large oven, X-rayed, and then robotically machined to meet precise thickness measurements.
Oh my
God!
God!
Yeah, you can see that is it becomes unbelievably expensive.
I hope you're listening, Marcus.
Yeah, well, one of the things that was quite funny was that they had to kind of start remanufacturing Avcoat, because they hadn't used it for a long time. So it was actually quite hard to get the Avcoat back to the performance level that it had been before.
Oh, really?
And one of the things they noticed was actually this time it hadn't actually cured off strong enough. So it was strong enough for the test mission that they did, but it's not strong enough when the spaceship has to go to extreme cold and then to extreme heat. So you can be going from ridiculously low temperatures to a very hot temperature. And obviously, as you know, when things do that, they tend to shatter or crack. So it's really, really important that doesn't happen.
That is insane.
So yeah, obviously the heat shield is one of the kind of major parts of the spacecraft. But,
and see, this is cool, because this is the reason we're talking about it. You don't hear about these things because on one side, people are like, oh, you know, it's kind of boring. Well, it's not when you think about what goes into it.
No.
It's insane.
And recently they've announced that Orion will use the laser communication system called Lemnos.
Yeah. Oh, yes.
Yes, Lemnos. And that will mean that they'll sort of have this super high broadband internet, essentially, which means that we could have high definition video, two-way high definition video. That means that when they do go to Mars or go to the Moon, we'll have amazing pictures. It's going to be absolutely cool.
And if they want to download any films just to watch on the flight, it'll be really quick.
So I want to get onto this really cool thing called the Deep Space Gateway.
We'll be the judge of that.
No, you will definitely think this is cool.
All right.
So we've talked a lot about the Moon, and I think this is going to be essentially a space station that they're building just in sort of lunar orbit. That means that it's kind of like a staging post for deeper space missions.
Cool.
And this looks like it's going to be the reason for Orion's existence, and SLS is coming to that.
So what you're saying is that eventually people will leave Earth, dock with the space station in lunar orbit, and then go on from there into outer space.
Yeah. So William Gerstenmaier, obviously the head of human exploration at NASA, he said, I envisage different partners, both international and commercial, contributing to the gateway and using it in a variety of ways with a system that can move to different orbits to enable a variety of missions. The gateway could move to support robotic or partner missions to the surface of the Moon, or to high lunar orbit to support missions departing from the gateway to other destinations in the solar system. How cool is that?
He sounds like a 1930s English Air Force officer.
What? With a name like William Gerstenmaier, he must be.
I'm not sure. I'm not sure. Let's get
him on. Let's get him on a show. Let's get him on. So so I've put out the little pictures of their timeline for all this.
Very cool.
And it actually starts soon. So one of the things that is really interesting is when the SLS and Orion are actually going to launch.
Yeah.
Because it was going to be 2018 that we were going to have this kind of initial test.
Yeah.
But now that 2018 initial test might be manned. That's like the recent thing. We talked about this on the podcast before, but that might be manned.
That's cool.
And then in 21, they might have another manned mission that goes round the Moon. So, which will be 3 years after Elon Musk says he's going to do it.
Yeah.
And then they're going to start building the Gateway in 2023. And that's going to be, and there's going to be exploration mission 3, 4, 5, 6, 7, 8, 9, 10 and 11 between 23 and 30. So between 2023 and 2030, they're going to be building this Gateway.
See, do you know what's really exciting about all this, Matt? Is it's not that far in the future. I mean, if you think about where we will be in, say, I don't know, 2050, I mean, we'll have done some incredible stuff. Who knows where we will have got to as well?
Well, it's just starting to get really exciting, isn't it?
Well, it seems like every month we mention something new that's happening in the future to further ourselves. I mean, this isn't like, every year something comes up where we're like, oh, wow, this is every month.
Yeah, and after 50 years of stagnation, and I think what the world really needs now is like this new inspirational story.
Absolutely.
And I think actually next week's guest, the Moon Express, is very much part of that. And I'm really looking forward to that one. So, tune in next week, for goodness sake, because we're going to have an amazing interview.
So, Matt, have we got any launches this week?
Yeah, so this week's been quite a good week for launches. We've had a Long March 7 yesterday.
Go China.
That launched the Tianzhou 1, which is a cargo spacecraft. I guess a bit like the ATV that we were talking about earlier on. And that has gone up to their space station, the Heavenly Palace.
Nice.
So that's a massively important one for the Chinese, because it's going to basically, it's their first robotic mission that's completely automated. So it kind of shows off quite a lot of their technical savvy.
Absolutely, they know what they're doing.
So that's pretty cool. We've also had the Soyuz MSO-4 that was carrying up the Fyodor Yurgikin for his fifth trip into space, and Jack D. Fisher, the American, for his first launch into space.
I'm so jealous.
So he's a test pilot. This is his first trip to space. But the really cool thing about that, instead of doing their normal 2-day orbit, they just went blasting straight up and did it in 6 hours. I just couldn't believe it.
6 hours straight into the space station.
I know. I watched the launch and thought, whoa. And then suddenly I thought, hang on a second, now the video of them going into the space station can't be right. Yeah. It was unbelievable. It was really cool.
Quicker than getting to Glasgow from London.
Yeah, and the Atlas V also took the John Glenn Cygnus cargo up to the International Space Station as well. So that's got loads of experiments on.
Excellent stuff.
Just after our last podcast, we had a Long March 3B that was taking a communication satellite up for the Chinese.
Nice. Well, it's been a good week all round.
Yeah, it has been. It's been a pretty epic week for the International Space Station.
I'll tell you one thing I wanted to mention, Matt, and that was the photo that you showed me of Cassini.
Oh, yes. So Cassini...
I mean, he's done some unbelievable shots, but this has got to be my favourite so far.
Of Earth? Is that the one where we're looking back at Earth?
And when you zoom in, you can see the moon. It's mind-blowing. I mean, the rings they look so still.
Yeah, I've started just going to the Cassini site every day, because it's going to be gone soon. But now is going to be some of the best photos. It's literally diving in between the inner rings and Saturn itself now. So this is going to be
incredible. So September's when it's officially kind of
going to burn up in the Saturn's atmosphere.
Yeah? Okay.
Particularly considering all these announcements that they've found organic. Well, no, the type of oceanic plumes that have been coming out of Enceladus and Europa, really look like that is these hydra. What are they called? Hydra vents.
Chris Hadfield was explaining it on TV yesterday, and he was saying that it's the same water that bred life on Earth.
Yeah, I mean
it's the same conditions.
Yeah, those hydra vents, volcanic hydra vents at the bottom of the ocean. Yeah, they're teeming in life. So
we shouldn't be looking to Mars. We should be looking to a moon.
Yeah, well, with the Deep Space Gateway, we can. That might be. In fact, Orion, the SLS and Orion and all these things might be one of the things that enable all that.
That's amazing. See, all these, we consider ourselves, in this big blue, just filled with water planet, which we are. But if you think how much more water they have on, not just in our solar system, I think we're like third last or something in terms of how much water we have. But you look at some moons, like some moons have more water than we do on Earth.
I mean, Europa has a lot more water.
Yeah.
Weirdly, it turns out that Pluto's got a sort of subsurface
Pluto
ocean.
absolutely does have more water than us. Yeah.
Oh, it's just crazy. It's been a really good week. So I think until next time, Jamie, I'm going to sign off now.
Me too.
But yes, next week, tune in because we've got a really great interview.
We've got
a
great interview with Bob, which we can't wait to show you next week. So tune in. Please keep commenting and subscribing. It's very important to us. We love the feedback. And have a good weekend.
Bye-bye, everyone.
Bye-bye.
See you next time.